Welcome to my new lecture. Let's start exercise 4.5. The first question. The first question states that we need to find the HCF and the LCM of the following. Now let's write the first part. In the first part, we have 16 minus 4x square, and then we have x square plus x minus 6. Let me remind you that the HCF is equal to the common factors, while uncommon factors are those factors which by HCF is divided. Now 16 minus 4x square can be further simplified and written as 4 square minus 2x whole square. Then we can simplify this much further and use the third identity, which is a square minus b square, and that is equal to a plus b and a minus b. Then we are going to place the values of a and b. So we can write 4 plus 2x, and then we will write 4 minus 2x. Now what is the common between the first term and the second term? We have 2. So we can write 2 bracket 2 plus x. And then for the second term, we can also write 2, and we will simplify it to 2 minus x. Now 4 and 4 will be multiplied with each other and they bring 4. Now here we will take the negative sign as a common value. So negative will be multiplied with 4, that results in negative 4 bracket 2 plus x. And then when the negative sign is applied, instead of having 2 minus x, we will have negative 2 plus x. Now negative 2 plus x can be written as x minus 2, and the rest negative 4 bracket 2 plus x will remain the same. So this is our first part, the first expression simplified. Now let's simplify the second part of the expression, which is x square plus x minus 6. Let's write it here, x square minus x minus 6. Now this is a quadratic equation. The coefficient of x square is 1. 1 multiplying negative 6 is equal to negative 6. So the factors of negative 6 are 3 and negative 2. So we can write x square plus 3x minus 2x minus 6, and then we are going to take the common value between the first term and the second term. So I can just write x bracket x plus 3, and in the second we'll take negative 2 as our common value and write x plus 3 again. So our first common term is x plus 3 and our second common term is x minus 2. So here we have x plus 3 and x minus 2. Now what are the next steps? We need to find the HCF. The HCF is the common factors. So in the first expression we have x minus 2, and in the second expression we have x minus 2 again. So we can just write x minus 2. And then we need to find the uncommon factors in order to find the LCM. So what are the uncommon factors? X minus 2 excluded, we're going to write all of the factors. So we can write negative 4 bracket 2 plus x, and then we can write x plus 3. Now we have the HCF and the uncommon values. Now we need to find the LCM. So the LCM is basically equal to the HCF multiply the uncommon values. So I can just write negative 4 bracket 2 plus x, x plus 3, and in the end I can just write x minus 2. So this is our final answer for question number 1, part 1. Now let's move on to the second part of question number 1. In the second part, we have a power 4 minus a power 3 minus a plus 1. Now what is the common between the first pair and the second pair? We can just pick a cube. So a cube bracket a minus 1, and then from the second we will just pick the sign of negative and then a minus 1. So a minus 1 is our first term and a cube minus 1 is our second. Now a cube minus 1 can be written as a cube minus 1 cube, That means we're going to use the identity that we learned in the previous chapters. Now, a cube minus 1 cube is equal to what? It is equal to a minus 1 and a square plus 1 plus a. So what are we going to do? We're basically going to remove a cube minus 1 cube and write this expanded form instead of it. So let me just erase it from here and bring this closer. And then a minus 1 will just remain as the same. So here we have a minus 1, a square plus 1 plus a. So this will be our final factorized expression. Okay, then the second expression, it states that we have a power 4 plus a power 2 plus 1. Now how will this be simplified? A power 4 can be written as a square whole square, and then 1 can just be written as 1. So a square whole square plus 1, and then at the end we can write a square. Now what is 2ab of a square and 1? That is 2a. So we can just write 2 bracket a square and 1, because this is the simplified form. Instead of writing a square, we are going to write 2a square multiplied by 1. And then at the end we are going to subtract this expanded form again. So we can write minus 2 bracket a square and then 1. Okay. Now what will happen is that this 2a square bracket 1 and here they both will be cancelled. So that just leaves us with a square plus 1 whole square. We just simplified it to make it easier for us. And then we can just write minus a square. So now we have the terms in a square minus b square. So we can just use the third identity and write a square plus 1 minus a, and then we can write a square plus 1 plus a. So this will be our final answer, the final factorized answer for the second part. Now what do we need to do? We need to find the HCF. The HCF is the common factors. So in the first we have a square plus 1 plus a, and in the second we also have that. So we can just write a square plus 1 plus a as our HCF. And then now we need to find our uncommon factors. The uncommon factors are what? They are a minus 1 and a minus 1. So we can just write a minus 1 only a single time. And after that we have a square. Then we have a square plus 1 minus a. So we are going to write a square plus 1 minus a. Okay, so after that we need to find the LCM. So the LCM is basically the product of both of these. So we can easily write a minus 1, and then we can write a square plus 1 plus a and a square plus 1 minus a. So this will be our final answer for question number 1 part 2. Now let's move on to the third part. Part number 3. In part number 3, we have the first expression as x cube plus 2x square minus 3x. Now how can we simplify this? Between these three terms, the common factor is x. So we can just write x bracket x square plus 2x minus 3. Now inside we have a quadratic expression where the coefficient of x square is 1 and it is being multiplied with negative 3, such that we need to find their factors. So this is pretty easy. We can just write x bracket x square minus 1x, or just simply negative x, added with 3x minus 3. After this we need to find the common. So we can just write x bracket x minus 1, and then we can write positive 3 bracket x minus 1 again. Now we will just write x bracket x minus 1 as our first term and x plus 3 as our second. Now this will be our first factorized expression. Now the second part of this expression is 2x cube plus 5x square minus 3x. Now how are we going to simplify this? we'll just do the same process, take x as a common value. So we can write x bracket 2x square plus 5x minus 3. Now what do we need to do next? We can just write x bracket 2x minus. Okay, now we have a quadratic expression inside where the coefficient of x square is 2 and here we have negative 3. So that is equal to negative 6. So how can we find the factors? We need to find the factors of negative 6. So we can just write x bracket 2x square minus x plus 6 and then subtracted with 3 at the end. After that we can just write x bracket 2x minus 1 and then we will take the common which is negative 3. So I can write negative 3 bracket 2x minus 1. After that we can just write x bracket 2x minus 1 as our common value and x minus 3 as our common value. Now what do we need to do? We need to find the HCF, which is the common factors. Now what is common between the first and the second? Here we have x and in the second we also have x. So we will just take x as our HCF and then we will find the uncommon factors. So everything except x will be the uncommon factors. So that means x minus 1 and x plus 3. So I can write x minus 1, x minus 3 and then I'll just add space here and then I can write 2x minus 1. So I'll just write here 2x minus 1. Okay, after that we will just write x plus 3 because that is also included. So now we have found the HCF and the uncommon factors, so we need the LCM. The LCM is basically the product of both HCF and uncommon factors. So we will just write x bracket x minus 1, x plus 3, x minus 3 and then we will write bracket 2x minus 1 at the end. So this is our final answer. Now let's move on to question number 2 and see what does it state. In question number 2, if the HCF and the LCM of two polynomials are given respectively, then you need to find the product of two polynomials. They're basically saying that we have two polynomials and the HCF of the first polynomial is given and that is x minus 7. And then we have also given the LCM, which is equal to what? That is equal to x cubed minus 10x square plus 11x plus 70. Now they are saying that we need to find the product of the two polynomials. That means that we need to find p of x being multiplied with p of q. We basically need to find the product of two polynomials. So how can we do this? Firstly, we will multiply the LCM with the HCF. That means that we're going to write x cube minus 10x square plus 11x plus 70 as it is, and then we're going to write x minus 7 being multiplied. Okay, so how will we do this? We will just write x minus 7 right here. So I will write x here minus 7. So both of these are being multiplied. They are not being subtracted with each other or not being divided. So x cube multiply x is x power 4. Then 10x with x will be negative 10x square. Sorry, negative 10x cube. So I will just write that. After that, I will write 11x square plus 70x. And then we need to multiply 7 with all of these values as the same. So we will write negative 7x. I think I made a mistake here. We are going to change this to cube. Okay, we will just write negative 7x cube. Then it will be added with 70x square minus 77x minus 490. After writing that, we will just simplify this much more further. So let's see how this will be simplified. So x power 4 will just remain as the same. And then we will write 17x cube plus 81x square minus 7x, and then negative 490 will just remain as the same. So now this is our answer. This is the product of P of x and P of q. Now let's move on to the third question. In the third question, we are given the product of two polynomials. The first is P of x and the second is P of q. We are given these products, which is equal to x power 4 plus 3x cube minus 12x square minus 20x, and then at the end we have positive 48. Now what do we need to do? We are also given the HCF, and the HCF is x minus 2. So we need to find the LCM. So in order to find the LCM, this whole product of P of x and P of q will be divided by this HCF, basically by using the division method. So we can simply write, we'll just write x cube plus 5x square. We will just write x power 4 plus 3x cube minus 12x square minus 20x plus 48 over here, and then we'll make a quick line. I'll then just copy this line and I'll duplicate it. I'll make it vertical and then I'll place it here. Okay, and then outside we can just write the HCF, which is x minus 2. Now x power 4 divided by x is x cube, so we're gonna put x cube in the quotient position, and that means that we're gonna have x power 4 right here. So x power 4 and x power 4 both will get cancelled and the resultant is 0. So we can just simply write 0 here. In question number 3, we are given the product of two polynomials, P of x and P of q, that is equal to x power 4 plus 3x cube minus 12x square minus 20x plus 48. And then we are also given the HCF. Now what is the HCF? The HCF is equal to x minus 2. Now we need to find the LCM. And in order to find the LCM, we are going to divide both of these terms. The first is the polynomial. It is the product of x and product of q, as well as the HCF. So we are going to use the division method. I'll just write here x power 4 minus 3x cube minus 12x square minus 20x plus 48. And then outside we're going to write x minus 2. Then we're going to just put this line here. We're going to select it and I'll turn that into a vertical line. Okay, so I'll just copy this and place it right here. Okay, now x power 4 divided by x is x cube, so we will write x cube right here. Now this quotient, which is x cube, will be multiplied with the first term and the second term. So that leaves us with x power 4 minus 2x cube. So the sign will be changed from positive to negative and negative to positive. And then we will just draw this line, and then x power 4 will be getting cancelled with x power 4. That leaves us with 0. Minus plus is minus and the sign is also minus. So that leaves us with positive. So plus and plus is always plus. So that leaves us with 5x cube. Now 5x cube, along with it negative 12x will come down and negative 20x as well. Now 5x cube will be divided with x. That leaves us with 5x square. So I will write 5x square again. Now 5x square is in the quotient, it will be multiplied with x and negative 2. So that leaves us with 5x cube. So I will write 5x cube here, and 5 2s are 10, negative 10x square. Then the sign will be changed. I will add the line. So they both will be cancelled. We will get 0. So minus plus is minus. So we will have negative 2x square minus 20x. Okay. Now what do we need to do next? We will also bring down 48 below. So we will write positive 48 here. Okay, now negative 2x square, it will be divided with x, that results in negative 2x. So I will write negative 2x here. This is in the quotient position, so it will be multiplied throughout these both terms. That results in negative 2x square. Negative negative will be positive. So we will just write negative for now because we're going to change the sign. This will be 4x. Now the sign will be changed from negative to positive and negative to positive again. Negative negative is positive. Negative negative is positive, so it will be changed to negative. So we are going to just draw a line now. They both will get cancelled. We will write 0, and minus minus is always minus minus. They both will be added with each other, but the sign will be minus. So we can just write 24x plus 48. Now we have negative 24x, that will be divided with x, that results in negative 24. So this quotient will be multiplied with both of our terms, that results in negative 24x minus minus into plus and 48. So the sign will be changed from negative to positive and positive to negative, and then we are going to draw a line here. Both of these will get cancelled with each other and our resultant is 0. So this means that our final answer of the LCM is equal to this quotient, which is x square plus 5x square minus 2x minus 24. Now let's move on to question number 4. Question number 4. In question number 4, we are given the product of two polynomials, which is y power 4 plus 6y cube minus 3y square subtracted from 56y, and then negative 48 at the end. And then we are given the LCM. The LCM is equal to y cube plus 2y square minus 11y. And as usual, we need to find the HCF. So in order to find the HCF, this product will be divided with our LCM. Okay, so firstly I'll just place y power 4 plus 6y cube minus 3y square minus 56y minus 48, and then we're going to draw a line. I'll just copy this line and I'll make it vertical. I'll add it here, and then outside we will write our LCM, which is y cube plus 2y square minus 11y. Now y power 4 will be divided with y cube, that results in y only. So y quotient will be multiplied throughout these polynomials. Now we will have y power 4 here, then we will get 2y cube and subtracted from 11y square. Now we will have negative sign here, negative sign and positive sign here, and then we will just draw a line. So these both will get cancelled, and then we have 6y cube minus 2y cube, that is 4y cube, minus into plus is minus, but the sign will be plus, so that leaves us with 8y square. Now 56y will be dropped down, and so is negative 48. Now y cube will be divided by 4y cube, so that leaves us with only 4. So we will write y plus 4. So 4 is in the quotient position. It will be multiplied throughout all of these polynomials. That leaves us with 4y cube plus 16y square minus 44y. 4 with 2 will be 8y square, and then we will have 44y. Then the sign will be changed from positive to negative, and negative to positive, and then we're going to draw a line. They both will be cancelled with each other, and so are they. Then minus into plus will be minus, and the sign will also be minus, and that is equal to negative 12y into 48. Now here we have negative 12y and negative 48. This is equal to 0. Suppose negative 12y is equal to 48. So negative 12 will be divided on both sides. That leaves us with the value of y being negative 4. And in the above we have y plus 4. So y plus 4 can be written as y is equal to negative 4. So this will be our final answer, which is y plus 4. Let's start with question number 5 first. We need to find the second polynomial when the first polynomial is given, the HCF is given, and the LCM is given. So how will we find the second polynomial? Well, look at the LCM. Here we have the first factor and here we have the second factor. So if we multiply both of these factors, then we can multiply that with our HCF. And then we need to divide that with our polynomial by using the division method. So if you multiply this first with this second, you will get x power 7 plus x power 6 minus x power 4 minus x power 3. And then when you get this value, you need to multiply this value again. With what value? With the HCF. So x power 7 plus x power 6 minus x power 4 minus x power 3 will be multiplied with x plus 1, which is our HCF. In the end, what you will get is x power 8 plus 2x power 7 plus x power 6 minus x power 2 minus 2x minus 1. Now we are going to use the division method. So let's look at the degree. Here we have x power 8 and here we have x power 4. So what do you think will go outside and what will go inside? Obviously the one with the greater power will go inside. So here we have placed this right here, and the degree with the smaller and the polynomial or the expression with the smaller degree will go outside, just like here. Now what is x power 8 divided by x power 4? That is x power 4. So that is placed in the quotient position. Now this x power 4 will be multiplied with the first term, with the second term, and it will be multiplied with the third term. So that results in x power 8 and x power 7. So both of these will cancel each other out. And here we have x power 7 plus x power 6 minus x power 5 minus x power 4 minus 2x minus 1. Okay, and then if you look here, we have x power 5 and x power 4. That is because we multiplied some of these values and they weren't present in here. So we placed them just aside and we changed the sign. So plus will be converted to minus and minus will be converted to plus. And then we divided it much further. So we have x power 5 minus 2x power 4 minus x power 3. We kept on dividing until and unless our degree was smaller than this degree. So if our degree was less than x power 4, so that meant we will not divide much further, but it was greater like 5 and 7, so we kept on dividing until we reached an answer of 0. So what will be our answer? This basically this quotient will be our answer. You need to just keep on dividing until you get the answer 0. Okay, so this will be your final answer. The answer to this question number 5 is x power 4 plus x power 3 minus x minus 1, just like I have written here, where we are given the first polynomial, which is this, then we are given the second polynomial, which is this, and then we are given the HCF. Now what can we do? Firstly, we will multiply both of these terms. If we were given the HCF and the LCM, we would multiply both of these, but here we are given the first and the second polynomial, so we are going to multiply both of them. So after multiplying both of them, what you will get? You will get this answer, which is 12x power 7 minus 38x power 6 plus 32x power 5 minus 14x power 4 plus 34x power cube minus 32x square. So after getting this value, then you need to divide it. Divide it with what? The HCF, by using the division method. So I've placed the smaller degree outside and the expression with the greater degree inside. So 12x power 7 divided by x is 12x power 6. So this is placed in the quotient position. It will be multiplied with the first term and then it will be multiplied with the second term. So here we get this, they will get cancel each other out, and we will get 26x power 6 plus 32x power 5. Then we will divide this negative 26 power x with this again, we will get negative 26x power 5. Then this is in our quotient position, so it will be multiplied with the first term and then it will be multiplied with the second term as usual. You need to keep on doing this process until the degree of your expression is smaller than that of the degree outside. So I kept on dividing and kept on dividing, but my answer still wouldn't ever reach 0. So that means that our answer is 32. But it is not just 32. Our final answer will be this quotient, which we got after dividing all of the values, which is 12x power 6 minus 26x power 5 plus 6x power 4 minus 8x power 3 plus 26x square added with 26x and 28, and with our remainder, which is 32. So this will be our final answer.